Hello everybody, we have the hints for day 4, so you're going to watch that video on graphing two variable inequalities. Up first we have this extended word problem that talks about the Martinez twins, and they're going to be putting together a space, a fenced-in backyard, where they can house pets, and they want to start up a business where they can house cats or dogs in various spaces. So 6 square feet for each cat and 24 square feet for dogs. And they have 360 square feet available in the storage shed for these pins and runs. Okay, they have this money they're going to invest for, and the cost for each cat pin and dog run is listed there. So you can kind of work your way through all this information and try to internalize it. Think about just exactly what they're trying to put together here. They're trying to start a business. They're going to have cat pens and dog runs. They cost a certain amount of money. They have this much money to invest, and try to put that all together in your head. Okay, and then they plan to charge $8 per day for cats and $20 per day for dogs. So maybe you can start to list this information someplace else, like on a separate sheet of paper. That's a good way to do it, and try to put all these quantities together into some sort of way that you can understand it. Now it says that really the question is, so after all this intro, like the question is, how many of each type of pet should they prepare for? Their dad suggested the same number of each, so 12 cats and 12 dogs. And Carlos thinks that they should plan for more dogs since they can charge more, and Clarita thinks they should plan for more cats since they take up less space and time, and therefore they can board more cats than they can dogs. So, what do you think? What do you think is the best situation, and what would your recommendations be to Carlos and Clarita? And kind of give your argument, your recommendation, and convince them that your recommendation is reasonable. So try to use those numbers based on the amount of space for cats and how much they're going to be able to get for housing the cats and the dogs. Try to make an argument one way or the other. And there really is no way that you can say that your answer is completely wrong unless it's just we're gonna not house any animals or something like that. So make a reasoned case that makes sense. Okay. Then go ahead and consider the amount of money available for purchasing the pins, and say that he thinks that the same number of each, 12 dogs and 12 cats, is too big. So why would you say that? So, and here's the hint. Take a look at the startup costs. How much money does it take for 12 cat pins and 12 dog pins, and compare that to the budget that they have to spend, right? Take a look at these different combinations. So, where does five cats and 7 dogs, where does that land? Is the startup cost too much for that? So we're starting to get into the inequality sense of things. Like it's going to cost you too much to house 12 dogs and 12 cats, maybe. So that's kind of out of their range of affordability. So we want to try to find some pairs of different numbers that do make sense, that do fit into their startup cost constraint. So try a couple of different numbers and see how it works out. And then that's kind of how that works. So, and then you can plot each of these combinations of points on the grid using a third color. Right, so you're going to plot each of these points using one color, another color, and a third color, and plot them on the graph to kind of see how they relate to each other. Okay, so that's the big part of this day, is figuring out how Carlos and Clarita are putting together their business. Then we just have some practice for you to do on basic inequality graphing. So this is kind of more the mechanics side of things. This is an actual application, but now we're just going to try to graph a bunch of them and see how they work. So you can go to Khan Academy, and you could put in this whole web address, or you could just go to Khan Academy and search for graphing inequalities, and I think it'll be faster way to look it up. So, and then you're going to do a couple of this is the example, but you're going to do more of them over here. Is you graph the line and then check a point. So is 0, 0 a solution? Basically, the line will cut it into a half plane. It'll cut it into two parts, and then you just have to find out which values are true. Are they true on this side of the line, or are they true on that side of the line? So if you get the point 0, 0, if it comes out that makes a true statement, so 0 is less than 4 is true, then that means that's a solution. So something on the other side of the line should not be true. So 0, 0 on the x, 7 is up here. So we test that point, and you see that you get 0 is less than or equal to 25, which is false. So none of these values on this side of the line would be true. So we shade this side of the line. Okay, and then because it could also be equal to the line, so less than or equal to, the line is drawn as solid. So if this was strictly less than, not actually equal to, then we draw the line as dashed to say it's not actually equal to the line. Okay, so that's what we do, is find out which side is it shaded on, and is the line dashed or solid. And that's your basic hints for that, and you're going to fill in your notebook and work on your performance task.